Hello Internet, my name is Quinn and this is Blondihacks. Got a very exciting topic for you today, boring heads. This is something I get asked a lot about. I think there's a lot of pros and cons to them that beginners don't necessarily grasp, so hopefully this will help you out a little, and there might be a few tricks in here for you journeymen as well. So let's go. What is a boring head? I like to think of them as someone having described a lathe over the phone to an alien, and they went bloop bloop bleep floop, which is alien for hold my beer, and made this. I suppose the most general description would be it's a way to mount a single point cutter in a milling machine in a way that gives you an adjustable radius. And of course that's most useful for boring on the mill, hence boring head. This end of course goes in the spindle on your mill. This has an R8 shank on it, but you can get other shanks for boring heads. And then there's a couple of holes in the bottom where you put your cutting tool. And the cutting tool is a standard boring bar. These tools have the same geometry as a boring bar in the lathe does. And in fact, you can often interchange them. And you'll see that there's two holes in the bottom. The spacing of these two holes is a little bit less than the distance of travel that you have on this adjuster screw here. So the range of motion of the screw gets you from one hole to the other so that you can do very large bores with the same amount of travel on this little lead screw here. Generally, you're going to want to start in the middle hole if you can, because the less extension you have on this slide, the more rigid the boring head's going to be. Basic boring head use is pretty straightforward. You're going to put this in your mill spindle, of course. Then you're going to choose your boring bar to go in the head. If you're using a kit like you just saw me open, it's going to come with a range of these little boring bars. They're all going to be compromises between reach and rigidity, the thickness of the shaft, and how small of a hole you can start with. Obviously, the thinner bars allow you to start with a smaller hole, which is often useful, but they're going to be less rigid because they're thinner, and then the longer ones are going to be more rigid if they're thicker, just like boring bars on a lathe, all the same trade-offs. So I'll put this boring bar here in the center hole as described, and tighten that down. As with any cutting tool, the next step is to touch off on the work so that you can start measuring your cut. So of course, if I'm working on this little sample bore here, immediately I can tell I'm going to have to move to the outer hole to get the reach necessary. Boring heads have one more quirk that we have to deal with before we can touch off on the work, however. We have to set the angle of the tool. Because these are round shank tools, that means that we can set this cutter at any angle we want, but we still have to get the cutting edge of the boring bar on center. There's no exceptions to the universe on this one. Cutting edges always have to be on center. Now, with a lot of boring head tools, that can be a little tricky because they often come with these brazed carbide boring tools, and these tools are very, very thick, as you can see. So the cutting edge is quite a bit above center line often on these tools. So an easy way around that, or perhaps a necessary way around that, unless you want to start regrinding all the tools, is you need to rotate this tool backwards to get the top surface of that carbide insert there, that brazed carbide piece on the center line of the cutter. The good news is it's enough to do this by eye. If you just bring the cutter down close to the work, generally as long as the front edge of the cutter is not going to be rubbing, and you've got this guy kind of visually what looks like to be at the highest point of the radius on the rotation there, then it's going to be close enough. And if it doesn't seem like it's cutting well, if it sounds like it's rubbing, then it's probably rotated too far this way. This side of the tool is probably rubbing on the cut. Or if it isn't cutting very well, but it isn't rubbing, then you can try rotating it forward a little bit more to get that top rake on there as close to zero as possible. As you can see, we've effectively got a negative top rake on this tool, which is not ideal for most materials, but honestly the same is true of lathe boring bars as well. A lot of insert and brazed carbide lathe boring bars actually have a negative rake built into them for the same reason, so that the side of the tool can clear the radius as you cut. To adjust the depth of cut on a boring head, there's always going to be, of course, the main lead screw here, which has got your graduations marked on there. Now, just like the cross slide on a hand wheel, you got to understand whether this is direct or indirect marking. In other words, whether one division on this scale represents a reduction in radius or diameter on the part. Generally, when you get a new boring head, if you're not sure, you're going to want to do test cuts because you really want to know before you start taking cuts that matter. It's very easy to overshoot your diameter by 2x if you aren't familiar with the boring head. Just like on a lathe cross slide, there's going to be a gib and locks on a boring head. On a lot of cheap boring heads, such as this one, they're all the same. So there's 3 little locking screws here, and you have to loosen all 3 of them. Some boring heads have separate lock and gib adjuster screws. Those are a little nicer, they're a little more efficient. On this particular cheapo boring head, you have to loosen and tighten all 3 of these between every cut. So I've got those loose. And I can dial in my depth of cut. Now, remember, we're trying to touch off on the work here, so I'm actually going to wind this back until I'm close to my surface. Then I can bring my quill down and adjust this guy until I'm just touching off on that surface, like so. And on a boring head, you just wind this back and forth until you feel it starting to touch your surface, and then you can call that 0. Generally speaking, unlike a lathe cross slide, however, there's no way to 0 this scale, so whatever number you're touched off on, that's your 0, and you're just going to have to make adjustments on depth of cut from here and checking the measurement of your bore as you go. So in this case, I'm going to dial in some depth of cut now. Let's say 10 thousandths. And then before I start cutting, I'm going to then have to lock this down again using all 3 of the screws on this particular boring head. Like so, and we're ready to cut. For speeds and feeds, there's no magic here. It's the same as any other cutting tool. You want the surface speed of that cutting edge to be correct for the material. So you can look up cutting speed tables in Machinery's Handbook, but the rule of thumb is going to be the same as for any large diameter cutter. It's probably going to be slower than you think. For feed rate, however, there's no free lunch here either. Just because this is a hole-making tool mounted in your spindle doesn't mean you get to use the quill and go fast. You still have to feed this slowly, just like you would a boring bar on the lathe. And that means you have to use the fine down feed on your mill. And this is where boring heads are a real pain in the patootie, especially if you don't have power down feed on your milling machine. So when it comes time to feed this, I can get close with the quill, but then I got to engage the fine feed, and you need to crank this down like so, nice and slow, so that you get a good surface finish on that bore, and you're not overloading the cutter with too many chips. All right, away we go. That's cutting well, but it's very squealy because that's how this aluminum cuts. That was about 650 RPM. Now it's cutting just fine, so that's probably the speed I would do that. Surface finish is very nice in there. That's the basics. However, let's talk about what's more important, I think, for the beginner, and that's when not to use the boring head. One of the things I learned from my commenters is the areas of machine shop work that tend to be misleading or unintuitive to beginners. And one of those is the utility of boring heads versus other methods of doing things. I've talked a lot on my channel before about how the lathe is generally the superior tool for doing most operations if they can be done on a lathe, because lathes are fundamentally more rigid, you've got more power feed axes, and it's generally easier to get good results with simpler tooling that's easier to grind and cheaper to acquire than on the milling machine. However, lathes require an intuitive lateral shift in your thinking that beginners tend not to have. Intuitively, to most people, the milling machine makes more sense. We're all intuitively used to the work being stationary and the cutter moving, and people think about operations more naturally in this kind of context. However, once you can get your head around the frames of reference that are created by spinning the work and leaving the tool stationary, all of a sudden your mind expands and the lathe makes much more sense. And you learn how to think of every operation in lathe terms instead of mill terms. So the boring head has a bit of that same intuitive leap problem. It's in a class of tooling with rotary tables as well, where beginners look at them and assume they are a good solution to most problems involving circular features or cutting large bores in this case. When in fact, the way to think about the boring head is that it's more like a last resort. It's generally the worst way to create a bore, except in the cases where there's no other way to do it. In which case it's still technically the worst way, but then it also becomes the best way by default. Beginners to machine shop work, and in particular armchair commenters, get very fixated on right or wrong, correct or incorrect. What's the one correct way to do something? In fact, I think it's much better to think in terms of nuance, pros and cons of each type of tooling. And boring heads have some pros, but they have a whole lot of cons. So if you're going to get involved in using this thing a lot and you think it's going to solve a lot of problems for you, it's best to understand what it's good at and what it isn't. The primary weakness of boring heads is that they are not very rigid. You can see how much length we're adding to the spindle already, and then we're adding this skinny little boring bar on top of that. And remember that this boring bar has to be long enough for the entire length of your bore. So for a reasonably deep bore, look at the length of cutter I need to add onto this. That is so much length that we're adding to the spindle. This is an enormous loss of rigidity. This is basically a wet noodle down here now that we're trying to cut steel with. This is going to deflect like crazy. It's going to be extremely prone to chatter. We're going to have to take very light cuts, which means lots and lots of passes for any kind of reasonable bore size. So loss of rigidity is the chief weakness of boring heads, I would say. Now compare that to boring on the lathe. First of all, we've got way more rigidity in here than the boring head has. Secondly, there might be some loss of rigidity here on the boring bar itself, but we can choose any diameter of boring bar we want on the lathe. So for that great big bore that I was doing in the aluminum, I can choose a great big boring bar and lose very little rigidity. Whereas on the boring head, you're constrained by whatever the size of the tool holder is in the boring head. So all your boring bars are necessarily thin and spindly. The next big weakness of the boring head is feed rate. As I said before, you can't just crank down on it with the quill. As with any other cutter, you need to have a nice fine feed rate to get a good quality finish. So that means you're going to be doing this with the little fine feed on your quill. And unless you've got a nice big industrial machine that has power down feed on it, most hobby mills do not, you're going to be doing this all the way down your bore. And let me tell you, this gets old real fast. And remember, this is one pass. Because boring heads aren't very rigid, we're going to be doing light cuts. So if you're trying to remove a 1/4 inch of material, let's say 10 thou per pass, you're looking at 20, 30 passes of doing this. Oh yes. Yep. That lathe is starting to look pretty good now, isn't it? Yep. Because of course on the lathe, when you're feeding a boring bar, you're using the power feed on your carriage. So you flip a lever and you stand back and drink tea while the machine does all the work. Similarly, when you need to feed in new depth of cut between passes on the lathe, you apply a little cross feed, lock it down, apply your power feed, and do your next pass. On a boring head, you gotta loosen all the little screws. Maybe it's 2, maybe it's 3, but you gotta loosen some number of these little screws. Of course, the head has to be stopped doing this unless your hands are a lot faster than mine. So you gotta shut the machine down, and then you come in here and you make your little adjustment. Oh, there's a little 5 or 10 thousandths there, and then you gotta lock it down again. And your fingers are getting sore from doing this 25 or 30 times, and now you can take another pass. That doesn't seem like a lot, but boy, that adds up when you have to do that on every single pass. And remember, on the lathe, it's boop, and you're done. All right, so boring heads suck, right? Well, they're still an essential tool because there are certain operations that can't be done really practically any other way unless you have really enormous machinery. The big one is doing bores in large pieces that can't be mounted in your lathe. And that comes up pretty regularly, even in model engineering like I do, where most of my components are quite small. I'm still dealing with things like boilers or occasional castings or other situations where it's not practical to mount it on the lathe and spin up the whole part. Now, if at all possible, I'm still going to do it on the lathe using a faceplate setup because that's still going to be a lot faster than the boring head, especially for a deep bore, but that's not always possible. So if you do a lot of work with large pieces and you do a lot of work with shallow bores and you have power down feed on your milling machine, then the boring head makes way more sense. And remember, everything I'm saying here is in the context of hobby work, where you probably don't have a very rigid mill, you have a small boring head that isn't very rigid, you don't have power down feed. If you're in an industrial shop with a big machine and a big boring head and you work on a lot of big castings, maybe you use the boring head a lot and it's perfectly reasonable in that scenario. So it's all about the kind of work that you do and what your options are for tooling and your machinery and so on. Again, no right or wrong here, just understanding the pros and cons, the weaknesses and strengths of the different approaches. If you do need to use the boring head in a hobby situation like this, you can do a lot to minimize the pain points on it. The number one thing you can do is start with a rough cut bore that is as close to finished dimension as possible. Think of the boring head as a finishing tool rather than a material removal tool. That'll save you a lot of grief. For example, you've got hole saws. These come in lots of different sizes. You can probably find one that's a little bit smaller than your finished dimension. You've got also annular cutters, which are a more deluxe version of a hole saw. They do a little nicer job, a little more accurate. They remove material a little nicer. And then, of course, you've got step bits. Sometimes these are just the ticket. And then, of course, regular drills as well. For that reason, if you anticipate needing the boring head a lot, I would invest in a good collection of hole saws. Because let's say the closest hole saw size you have is, say, 1/4 of an inch smaller than your bore, and it's a reasonably deep bore, you're going to have to do 25, 30 passes, something like that. It's honestly probably faster to drive to the hardware store and buy a closer fitting hole saw than it is to try and do all of that work with the boring head. Just don't cut it too close, because hole saws can cut oversized or they can cut a little bit out of round, so you don't want to cut it so close to your final dimension that you don't have enough material to remove to clean it up and get good roundness. Just like any other roughing operation, you want to be close to your final dimension, but not too close. Alright, so you've decided you can live with the weaknesses of a boring head in order to get the strengths of it. How do you go about buying one? The good news is, for the hobbyist, you don't have to spend a whole ton of money on these things. This kit here is from Little Machine Shop, hashtag not sponsored, but it's been just fine for me. This little guy has done everything I've asked it to. The build quality on it is totally reasonable, and it does a fine job. Now, it does come with these brazed carbide cutters, as I said, and they can be a little finicky. They can be a little difficult to get on center. You don't necessarily have to use these if you don't like them. You could certainly buy a nicer set of boring bar cutters for use in a boring head. You can get insert cutters, you can get high-speed steel cutters, you can grind your own high-speed steel cutters, you can get high-speed steel insert cutters. So there's lots of options for this to improve the cutters if you don't like them, but once you kind of get used to the quirks of these cheapo brazed carbide, they work okay. The main thing is to make sure you match the shank on your milling machine, of course. This is an R8 shank because I have an R8 taper in my milling machine. But here's something you may not know about boring heads. When I was first starting out, I didn't know this. The shanks on these are removable, and in fact, the threads on them are reasonably standardized. There's only a couple of different threads that they typically use on these, so you can get different shanks on them, which is pretty useful. For example, I also have a straight shank for this boring head. And what's nice about this is that you can put it in a collet, for example, in the lathe. So you can do some stunts with a boring head in the spindle on your lathe. Well, you can use a boring head to do large facing operations on, let's say, a big casting mounted on your cross slide. You could also, in principle, stick this guy in a collet in your mill and not have to buy a special shank that matches your spindle taper. That might be the only option if you have, say, an unusual taper in your mill, if it's a very old mill or an unusual one, and you can't get the right shank for it. However, I would not do that unless you have to, because this is going to cost you a lot of rigidity. And you've already got a serious rigidity problem with a boring head, so if you go and stick a straight shank and a collet on top of that, it's going to get 10 times worse. You really want the rigidity afforded by a direct interface to your spindle taper. But the other nice thing about these interchangeable shanks is that you can then buy an additional boring head if you want and use the same shanks in it. This one is actually the cheapest one that I could find on eBay, I think, and the build quality on it is frankly not great, but for a specific operation, I really needed a great big boring head. In fact, it was used in that clip that I showed you of facing on the lathe. So in a pinch, I do have this guy for when I need to do really big bores, but it's not very useful. However, I was able to save a bunch of money on it because I can use the same shanks on both of these boring heads because I was careful to choose one that has the same thread on both. I'll finish up by showing you a few cool stunts that you can do with boring heads because they have a few more tricks up their sleeve besides just cutting bores. Of note is that most of them have this additional hole on the side. So what would that be for? Well, you can put a cutter in there, and this allows you to create large arc features on a part. You can imagine bringing this down on a part like so, and you can cut a big, like half circle or partial circle groove in the side of a part. Or you could fish mouth the entire side of a part by feeding that all the way down the side of the part. In a sense, this becomes a giant fly cutter. And in fact, with the right tool geometry, you can use a boring head as a fly cutter. It's a lot less rigid than a normal fly cutter is, but you can in fact feed your table in X or Y with boring head like this and use it as a fly cutter. Here's a really cool trick that I've seen others do. I'm not set up for it, so I can't demonstrate it, but let's say you've got a Morse taper shank on your boring head so that you can mount it in your lathe tailstock, then turn yourself a dead center that can be mounted in the front of the boring head here. And now look what you've got. You've got a very accurately offsettable dead center. And what that allows you to do is taper turning without messing up the alignment on your tailstock. Now, this whole setup isn't going to be super rigid because we're talking about adding a lot of length to your tailstock, but for a lot of operations, light cuts, easy cutting material, I'm sure that works just fine. So cool trick, keep that one in mind. And don't be afraid to think outside the circle. You can face your cutter inwards like this. There's nothing stopping you then from feeding the cutter outwards like so, and now you can turn an OD with the boring head. There might be an operation where you need to turn a shaft that's part of a casting, something like that. You need to create an outside diameter on a part. There's no way to mount it in the lathe. You can do that with the boring head. Now, of course, this is a normal right-hand cutter, and now we've got the cutting edge going the wrong way. So either you're going to have to run your spindle in reverse, or you need to use a left-hand boring bar like this guy, such that when it's facing inward, the cutting direction is correct. So make sure that you can run your mill in reverse at full power before you try this, or else get the right type of boring bar. Even more exotic, this setup can be used in combination with holding the work in a spin fixture at an angle to do ball turning. This is a very, very exotic and cool technique. The best video I think on this on the internet is by Stefan, so I'll link to his video below. He can explain it much better than I can, but just know that you can use a boring head for ball turning on the mill. There you go. That's my quick introduction to boring heads. I hope you found something useful in here. Maybe learned a new trick if you already knew about these guys. Either way, thank you very much for watching. Thanks especially to my patrons for making all of this content happen, and I will see you next time.